question 3 says, if h of x is equals to minus 1, x plus g squared plus 4 minus r, then what is the probability that if you throw the two dice and place the values into hx, that the roots of hx will be non-real? Okay, so the shape of our graph, we can see that A is negative. So that means that the shape of our graph would be then a sad shape, right? So in order for the reals to be non-real, it means that the graph must not touch the x-axis. It must look like this, right? It must not touch the x-axis. Now, our turning points from looking at the graph, we can see so the turning point, the y value is given by 4 minus r. So it means that 4 minus r must be greater, actually must be less than 0, because we want it in the negative x-axis there. So this must be less than 0. Then we will get negative r must be less than negative 4. We will divide both sides by negative 1. Then r must be greater than 4. So on our dice, there are two numbers that are greater than 4, right? For our red dice, there will be two numbers that are greater than 4. This is 5 and 6. So the possibility then becomes a 2 out of 6 or a 1 out of 3. Or we can try and solve it algebraically by then saying, okay, we understand h of x is equals to minus 1x plus g squared plus 4 minus 1r. We'll multiply out. We get minus 1 is x squared plus 2xg plus g squared, and we'll get plus 4 minus r, and this will be minus x squared minus gx plus g squared plus 4 minus r. So in order for us to have non-real numbers, then our determinant needs to be less than 0. If we look at our equation, our A is equals to, we're missing a 2 here. Our A is equals to negative 1. Our B is equals to a minus 2G. And our C is equals to G, the minus missing here, minus G squared plus 4 minus R. So our determinant is given by B squared minus 4AC. So B is minus 2G squared minus 4. Our A is negative 1, and our C is minus G plus 4 minus R. Right, and this will then simplify to 4G squared minus 4G squared minus plus 16, and then we have a minus 4r squared. So we will then have here 16 minus 4r squared, and this must then be less than 0. So let's see. You have minus 4r squared less than a negative 16. Divide both sides by negative 16. And then we'll have r squared must be greater than 4. Okay, so must be greater than 4. This is supposed to be just r. I made a mistake by putting an r here. So if you can see, it's coming from this multiplication, so it's not supposed to be a squared. So then R must be greater than 4. Again, there's only two numbers that are greater than 4. It's going to be 5 and 6. Therefore, the possibility is 2 over 6, and that gives us 1 over 3.